Okay, so that's nice, but really all we're doing is saying when do these different things develop. Really what we want to know is how does that whole system develop? And in particular, what is the role of experience and genes, and how do they interact to produce this amazing system we all have? I'm not going to answer that. I'm going to dance around it a little bit. Okay, it's really hard, but there's some cool things. Okay, so are there effects of experience on face perception? Absolutely, right? The most obvious one is there are particular people you know, if you've met them before, and you're okay at face recognition, and you see them later, you'll remember them. That's an effective experience, right? We don't usually think of that as a change in the whole face recognition system. It's just you've stored that face in memory. Okay, but it's worth mentioning that's one aspect of how experience affects face recognition. There are others, though. There's something called the other race effect. I might have mentioned this last time, I'm not sure. This consists in the fact that they all look the same. Whoever they are, if I have less experience with them than with my people, whoever my people are, then they all look more similar to each other than my people look. And this is a simple product of experience. You have a lot of experience with a particular race of faces, you can become better at discriminating them from each other. Okay? So that's an example of experience, although I'll tell you an important twist on it in a moment. There's also an other species effect. Okay? In the other species effect, we're better at discriminating one person's face from another person's face than we are at discriminating, say, a monkey face from another monkey face. Or maybe not. Let's try it. Okay, so look at this monkey face, okay? Okay, now I'm going to show you another monkey face in a moment, and you're going to tell me if it's the same or different as the one I just showed you. Okay, here we go. Same or different? Don't know. Okay, remember what that felt like. Now we're going to try a human face. Okay, look at that for a moment. Okay, I'm going to ask you in a moment whether that's the same or different as this one. Okay, which was harder? First one. I cheated a little bit by having it first before you could get your strategy going. It's important to know how to cheat with your demos so they work. No, it works even if you don't cheat. It's just a little clearer if you do. So you guys experience what the literature shows, that it's much easier to discriminate faces of your own species and another species. But here's the really astonishing thing. When you were 6 months old, you could discriminate those monkey faces better than you can right now. So really what experience does in this case is not teach you new abilities. It's used to edit out abilities, to throw out abilities. This is called perceptual narrowing. And really it's a phenomenon in which your experience with a certain race or species of faces doesn't improve your ability to discriminate faces of that race or species. Rather, it trains your system to throw out your ability to discriminate faces of another race or species. Yeah?
Were they different?
Sorry?
Monkeys, were they different?
Yeah, they were both different. Yeah. Yeah. Okay, oops, going the wrong way. Okay, so just to show you a little teeny bit of data on this, I gave you the essence of it. So what these guys did was use that same preferential looking paradigm that I showed you before. You bore the kids with the infants with one face, and then you switch to a new face and you ask if they look longer, which is a measure that they can tell the difference. And what they find is that 6 months olds, 9 months olds, and adults can discriminate faces by this preferred looking measure. Okay, no major surprise there. Okay. Okay. Now when you do that same experiment with monkey faces, you find that adults and 9-month-olds can't discriminate the monkeys, much as you just experienced. Okay? But here's the data from 6-month-olds. They can. So you all had that ability and you lost it. It's kind of poignant, isn't it? Okay, so this is just like something else you may have heard of, perceptual narrowing in the case of phoneme perception. So if any of you are native speakers of another language, there may be phonemes that make an important discrimination in that other language, but not in English, and you can hear those differences, but your friends who don't speak that language have no idea what you're talking about. They can't hear those subtle differences. Well, each of you could discriminate all of the phonemes of all of the world's languages when you were 6 months old. and you have lost those abilities, okay, for any languages that you don't speak. So it's just like faces. You start with this equipotential system that can do all of these discriminations, and what experience does is not train new ones, it tells you which ones to throw out. Yeah?
Have you shown that, I don't know, that maybe infants or that have been exposed to faces of monkeys, like keep that until adulthood?
Did you look at my slides in advance? Yes, indeed. Okay, so can you reverse it or avoid it in the first place? Absolutely. There's a lovely study where what they did was they took 6-month-olds who can remember, who can discriminate those monkey faces. And they wanted to know what is required to preserve that ability, to prevent it from going away. So they sent the parents home with books with pictures of monkeys, with one of two instructions. The parents were supposed to read the monkey books with the kids, pointing to the monkeys in the books, with one of two comments. In one case, they just said monkey, monkey, monkey. Okay? In the other case, they named the different monkeys with different names, as indicated. Only the kids who had the experience with the monkeys being named as individuals maintained that ability until 9 months. The kids who had the same experience looking at the faces, but where the parent just said monkey, 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 lost the ability, the normal perceptual narrowing effect. Okay, so if you direct attention and force it not just to see those stimuli, but to do the discriminations on them, then that ability lasts. There's a similar case in humans where they looked at kids, international adoption, kids who were adopted from Korean families between age 3 and 9 years, and who moved to France and grew up with French families. And they tested them later in childhood, and they found that those kids showed other race effects in which they could discriminate Caucasian faces, not Korean faces, which presumably they could discriminate when they were younger. So this is a case where the early perceptual narrowing effect was reversed with later experience. Okay. Okay. Yeah.
How long is the necessary exposure for the kids in the top one in order for them to keep it into adulthood?
I think they tested them at 6 months, sent them home with the monkey books at 6 months, and brought them back around 9 months. Otherwise it's hard to do the experiment. You've got to keep the parents doing this. How long are the parents going to go through the monkey book? Whether it could last longer, I don't know. You'd have to do something more extreme to convince the parents and the kids to keep looking at monkeys.
Did they test them afterwards? Again?
Oh, that's a very good question, and I don't know. I don't think so. Here's the citation. You could look it up. If you find it out, let me know. Yeah.
Do we know if the time to reverse the perceptual narrowing changes according to age?
Yeah, I mean, like if there's a window that goes away. Yeah, it's a very good question. I think it's gonna vary with all of these. I think it's a very interesting question. It hasn't totally been nailed. This example with the international adoption is the closest one I know, but it raises all these questions. Well, what about if they'd been adopted later? Or actually something I've always wanted to do and never got around to doing is find, say, graduate students who move here from, rural China or something like that, and haven't had as much experience with Caucasian faces until they get here at age 20-something, right? That would be cool. Is it reversible then? There may be a critical period beyond which you can't. It certainly seems to be the case with phonemes. I mean, try learning another language that, as an adult, that has a phonemic discrimination. There's some people who seem to be able to do it, but most people find that extremely difficult. Yeah.
Is the perceptual narrowing specific to each individual kind of perception? Is it, or is there overlap between the phonemes and the faces? So, if someone was exposed to kind of reverse the narrowing effect.
I mean, are the time windows the same?
No, the kinds of stimulus that the person is receiving. Is this?
Oh, yeah, very specific. That's
so,
right.
If the narrowing is reversed for the phonemes, is there any evidence that the other race effect might also?
Oh, I'd be astonished. No, it's pretty clearly with that class of stimuli.
Okay. Because otherwise it'd be some sort of some mechanism in the brain that's doing
It can't be the case that if you send parents home with a monkey book and tell them monkey A, monkey B, monkey C, that the kid's whole brain becomes more plastic. Okay. That would be cool, but but I don't think so. Okay. All right. So those are some examples of how experience affects perception, but now we want to know, well, are there any abilities that are present without any experience at all? So the most astonishing experiment, I refer to as the Uber experiment here, by Sugita, what he did was to raise baby monkeys for 6, 12, or 24 months without ever letting them see a face. So before you pity the monkeys, actually their lives were okay. They had lots of cuddling and lots of care by human caregivers who simply had hoods over their heads. Okay, so they had rich visual environments, lots of social experience, lots of cuddling. They just never saw faces. Okay, so then when the monkeys were 6, 12, or 24 months old, for different monkeys, they used preferential looking, just like we've been talking about, to ask how good their face discrimination ability was. Okay, everybody see the point here? Okay. And first of all, on the very first exposure to faces, the monkeys were extremely interested in faces, just like that baby monkey I showed you before, and they looked at the faces a lot. Okay, so that preferential looking to faces compared to everything else was there, even though they'd never seen faces before.
Across the times, so they all.
At a 2-year-old monkey, who's a fully adult monkey, who's never seen a face in his life, the first time he sees a face, he does that. It's like, where have you been? Right? Yeah. Okay, but the really astonishing thing is when you do the preferential looking to measure ability to discriminate one face from another, actually very difficult face discriminations with no hair and with very similar faces, these monkeys behaved like normal adult monkeys. Fully intact, normal adult face recognition, and they have never seen a face in their life before. That's astonishing. I'm all for nativist theories, but this is nuts. I mean, it's a really nicely done study. Now, it's not the case that this study found no effective experience. So that's the main result. But they did find an effective experience. So what they did then, after this experiment, they then took those monkeys at either of those 3 ages, and they then put them in an environment for the next month with only humans or only monkeys. And then they tested them again. And they found perceptual narrowing. In other words, a monkey raised for 2 years without ever seeing a face is then put in an environment with humans for a month. At the beginning of that time, they're very good at discriminating both human faces and monkey faces. Okay? After a month of experience with human faces, you then put them in an environment with monkeys, and you test them on monkey face discrimination, and they can't do it. And in this experiment, they left them in that environment with other monkeys for a year or 2, and they never got the ability. It's kind of sad, actually, monkey face discrimination. So that's perceptual narrowing that's delayed, that starts at the beginning of exposure, and that never flips back. Yeah.
So to maximize the amount of faces we can recognize and phonemes we should just like never look at faces and never learn language until
Right. Well, I don't know if this would work with phonemes as well. And remember, this is monkeys, not humans. I'm dying to know if this would be true with humans, but obviously we can't do the experiment, right? So, so that's why these experiments are so powerful. This is why I keep saying that there's so much more you can do with monkeys than you can do with humans. It's really getting at this very deep question of the role of experience. Yeah.
So the result was that these did not experience any kind of perceptual narrowing?
They did after the first exposure.
So the first exposure,
Okay, so let's just say, at the first exposure, they are adult-like at discriminating monkey faces and human faces, just as if they'd had 2 years of experience. They're adult-like. Now you take them and you put them in an environment with, say, just other monkeys. Now you test them again a month later. Now they can only do monkeys, not humans.
Okay.
And that doesn't reverse. That's it.
And if you keep them in
So it's like a
mixed environment-
switch. Sorry?
If you keep them in a mixed environment, do they retain both?
That's a good question. They didn't do that in this study. Presumably. Like the experiment where they send the book home with the parents. Yeah. Okay. So all of this to say that even though we don't really know how face recognition develops, we have a bunch of clues. Namely, experience has some role, namely the perceptual narrowing. But in the extreme case, with no experience whatsoever, at least in this one study, the baby monkeys were adult-like in their ability. That result is so astonishing to me that even though I think it's a beautiful study and I see nothing wrong with it, I'm still waiting for somebody to replicate it because it's such an extreme nativist result, right? Unfortunately, it's an extremely difficult study to do, so it's not clear anyone will do it. But. Okay, all of that was to look at the development of face perception and to say that most of our face perception abilities are present extremely early, many of them within 2 days of birth, all of them within 4 years of birth. And the role of experience is clearest one is in perceptual narrowing.